In this video, I want to take a look at finding the turning point by completing the square. Now, one of the useful properties of completing the square is that it gives us the coordinates of the turning point. And this is particularly useful for being able to sketch a quadratic. So let's just take a look at these two examples here and just kind of illustrate what we've got. So what I've got here is a positive quadratic, and same here. Okay, so they're going to have a U shape. So let's just say, for example, it's going to look, say, something like this. Okay, it might look something like that. Now, I don't know if that matches to either of these quadratics, but just as an example, this would be our U-shaped quadratic. So it's going to be a positive quadratic, like these two examples here. And we would have a turning point, and in this case, it would actually be a minimum turning point, and it might be, say, here at the bottom. Okay, so let's just mark that in with a different pen color. Let's do that in red. So I would have this point here, and let's say that's our minimum point, okay, or our minimum turning point. So, like I said, one of the useful properties of being able to complete the square is that we can actually get the coordinates of that minimum point. So, if we take our quadratic here, let's complete the square on it, and then let's see how we get the coordinates of the turning point. So, complete the square on this quadratic here, we get x plus 2 all squared. We subtract this value squared, so that would be minus 4, and then don't forget the plus 7 here. Okay, so plus 7. We now need to simplify here, so I get x plus 2 all squared, minus 4 plus 7, well, that would give me plus 3. Okay, and this is perfect. We've completed the square on this, so what we were looking to do here is write the equation in completed square form. So that's x plus a all squared plus b. Okay, we were looking to do that. So once we've got it into this form here, like we have here, then we've done all the hard work. We now just simply need to read off the solution. So the turning point in this case, so therefore the turning point, that's given by looking at our solution. So the x coordinate is given by the part inside the bracket, and it's the opposite to this number. So if this is positive 2, our x coordinate will be minus 2. Okay, if it had been, say, minus 4, then our x coordinate would have been positive 4. So like I said, it's always the opposite sign. The y coordinate is this value here on the outside, and we do keep the sign the same. So if it's positive 3, our y coordinate will be also positive 3. Okay, so in that case, our turning point will be minus 2, 3. So clearly, our diagram definitely doesn't match here, but just so we could kind of get an example of what we were looking at, that's what we found there. So a turning point, which in this case will also be a minimum point. So that's the solution to the first example. Let's take a look at this example here now. Now it says, by completing the square, find the coordinates of the turning point of the curve with the following equation. So again, all we do here is we complete the square. So we get x. We divide this coefficient of x here by 2, so that's x minus 5 all squared. We subtract this value squared, so minus 25. And then don't forget the minus 1 here. Okay, clean this up now, so we get x minus 5 all squared, minus 25 minus 1 gives us minus 26 there. Okay, and again here, all we do is we simply read off the coordinates. So the turning point is given by the following coordinates for this example. So with this being x minus 5, so it's minus 5, we take the opposite sign, so that will be positive 5 for the x coordinate. And for the y coordinate here, that's minus 26, and we take that sign as it is, so it's going to be minus 26 there. Okay, so our turning point is 5 minus 26 for the second example. Now, I also just want to go through one more example here, where the coefficient of x squared is not equal to 1. Now, we do know how to complete the square on something like this, where the coefficient of x squared is not 1. And to find the coordinates of the turning point, when we have a quadratic like this, we just follow the same method. So again, all I'm going to do here is start by completing the square. And to do this, we first need to factor out this coefficient here of x squared. So I get 3 lots of, well, I take the 3 outside. We're now going to get a quadratic inside the square bracket here, so we're going to get x squared. We get 10 over 3, so we get 10 over 3x, and then we get 1 over 3. Okay, so we've factored the 3 out here. Now, to be honest, this example is quite tricky. And the reason why is because we've got this 10 over 3 here. So sometimes you might get an integer here, so it might have been, say, 2x. In this case, it's not, and this makes life a little bit more difficult. And the reason why is because we can now complete the square on this quadratic, that's fine. But once I divide this coefficient of x here by 2, we've got this fraction, so it just makes life more difficult than it needs to be, basically. So let's keep the 3 on the outside. Let's now complete the square on this quadratic here. So we get x. Now you've got 10 over 3. If you divide that by 2, that's the same as times in by a half. Okay, so dividing by 2 is the same as times in by a half. So in other words, I've got 10 over 3 times by a half. And that will give me 10 over 6 there. Okay. Now, obviously, you could do 10 over 3 divided by 2, and then change that to have a denominator of 1. Change that division to be a times and flip that, but notice you just get the same as what we had here. Okay, but just remember, dividing by 2, the same as times in by a half. So we get plus 10 over 6x, sorry, 10 over 6, and then we square this bracket here, ignore me. And now we subtract this value squared. Now we want to make life a little bit easier here. What we could do is we could write this as 5 over 3. So let's do that just to make life easier. So 10 over 6, that's the same as 5 over 3. So we get 5 over 3. And the reason I'm doing that is because we now need to subtract this value squared. That's going to give me minus 25 over 9. So minus 25 over 9. And don't forget we've got this plus 1 over 3 here. So plus 1 over 3. So we need to simplify this part here. So minus 25 over 9 plus 1 over 3. Well, we need to make this denominator here of this 3 become a 9. So we just times this fraction here by 3. So times that by 3. Okay. I'm going to get minus 25 over 9 plus 3 over 9. And in that case, then I'm going to get minus 22 over 9 there. Okay. We get 3 lots. Keep the bracket as it is for now. So x plus 5 over 3 all squared. And then we get minus 22 over 9. Okay. Now, to finish with here, what we need to do is we need to multiply through now by this coefficient that we factored out before, the 3. So we get 3 lots of x plus 5 over 3 all squared. And then we've got minus 22 over 9 times that by 3. So minus 22 over 9 times that by 3. So that's 3 over 1. So this 3 here will cancel with this 9, giving me 3 in the denominator here. So I get minus 22 over 3 there. Okay, so I'd get, that would be a 1. So minus 22 times 1 would give me minus 22. 3 times 1 would give me 3 there. So we get minus 22 over 3. Like I said, this example is quite tricky, especially considering that you wouldn't generally have a calculator for something like this. So we now need the coordinates of the turning point, and it actually doesn't change even when we have a coefficient of x squared that's not 1. Okay, so in this case, we just read off now the turning point just like we would for the previous examples. Okay, so for the turning point here, that will be given by, so let's just note this here, minus 5 over 3. So because this is positive 5 over 3, that would be minus 5 over 3. And my y coordinate, again, keep the sign as it is, that would be minus 22 over 3 there. Okay, and there we have it. So that's our solution to the final example. Like I said, though, this is quite a tricky example. You probably don't want to get something quite this tricky, although you can. So don't expect this to not come up. It can definitely come up. Okay, so that's our solution to the final example. So now it's your turn to have a go at a couple of practice questions. Now, feel free to start with this one first. This is the more straightforward example, and then have a go at this question here. So pause the video now, have a quick go, and then we'll take a look in a moment at what you should have got. So hopefully you got an okay with these two practice questions. Let's take a look now at what you should have got. So like I said, let's start with this example here. It's probably, well, it's definitely easier than this one. So let's take a look here. So we just want to find the coordinates of the turning point. So the first thing we do is we start by completing the square. So we get x minus 1 here because we divide minus 2 by 2. So we get x minus 1 squared. We subtract this value squared here. So we get minus 1, and don't forget the plus 3. So now we just need to simplify here. So I get x minus 1 all squared, minus 1 plus 3. So that's going to give me plus 2 there. So now we can simply denote the turning point, or the coordinates of the turning point. And that will be given by positive 1. So because that's minus 1 there, we take the opposite sign. So that's positive 1 and then positive 2 as well. So we get 1, 2 there for the coordinates of the turning point. And for the final question here, definitely the trickier of the two questions because our coefficient of x squared is not 1. So in that case, we need to factor this 2 out. So we get 2 on the outside. I'm going to get x squared. I'm going to get minus x here. And then we get plus 7 over 2 even at the very end. Okay. We can now complete the square on this quadratic here because the coefficient of x squared is 1. So keep the 2 on the outside. We now get x. So this is where it can get a bit trickier again. So this coefficient of x here is 1. So when we divide that by 2, we get a half. So we get minus a half there. Okay. We square this bracket and I subtract this value squared. So I get minus 1 over 4 plus 7 over 2. Okay. We need to just keep simplifying here. So finish that off up here. So I'm going to keep the 2 on the outside. I've got x minus a half here inside this bracket, all squared. I've got minus 1 over 4 plus 7 over 2. So we need to just times this by 2 here. So we've got a denominator of 4. So that's going to give me 14 over 4. So I've got minus 1 over 4 plus 14 over 4. And again, just keep simplifying here. So a little bit tedious, but we'll get there. So minus 1 over 2, all squared. Minus 1 over 4 plus 14 over 4. That's going to give me 13 over 4 there. Okay, so 13 over 4. And from here now, to finish this off, we just need to times through by 2, and then we can read the coordinates of the turning point. So we get 2 lots of x minus a half all squared. So we've got 13 over 4 times that by 2, so 13 over 4 times that by 2. That 2 there will cancel with this 4 partially, so I'll get denominator of 2 there. I'm going to get 13 over 2 basically, so plus 13 over 2. So therefore, the turning point is given by reading off now our coordinate. So turning point is equal to, so this is minus a half, so our x coordinate will be positive a half. And our y coordinate here will be 13 over 2. Okay. And there we have it. So that's our solution to the final question. So that brings us to the end of this video. In the next video, we're going to take a look at how to solve quadratic equations by completing the square.